Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to understand parallel vectors and collinear points. When are vectors parallel? Vectors are parallel when they are actually in the same direction. These two vectors are parallel. Incidentally, when they can be expressed as a scalar multiple of each other, for example, A and B, you would want to say that 2A is equals to B. 2A is equals to B. Those vectors are parallel. Vectors are parallel when they can be expressed as a scalar multiple of each other. A scalar multiple of each other. Those vectors are said to be parallel. What happens when the two vectors both lie on the same line? When we have probably vector A there, and we may want to combine with vector B in the same direction that way, whereby we can have vector A and vector B up to there, then they are sharing a point in common. If we say this is AB and then vector B is BC, it has to be BC. They are sharing point B. It means therefore the vector 2A still continues to be equals to B, and at this time, if you may want to use the terminal point, we are going to say 2AB is equals to BC. It is true the two vectors have been expressed as a scalar multiple of each other, and the fact that they are sharing point B, now that they are sharing this point B, then we can say the two vectors are parallel, and the 3 points A, B, C are collinear. Points are collinear when we have two vectors which are parallel lying in the same line. But I want to make something clear here. Only vectors can be parallel. Only vectors can be parallel. Points cannot be parallel. At the same time, only points can be collinear. Vectors cannot be collinear. Only vectors can be parallel and only points can be collinear. There is no way vectors can be collinear. Collinear means they lie on the same straight line. AC is a straight line, but within AC we have vector AB and vector BC. We could also have vector AC and vector AB. We have several vectors there. But if we are able to express those vectors as parallel vectors, and they have to have a point in common, then the 3 points are collinear. And we need to stress something here. For collinearity, we have to have two parallel vectors and a shared point. Let me just put this down. For points to be, or for collinearity, we have to have two vectors which are parallel and a shared point, and a point that is shared by the two vectors we are talking about. The least number of points to be collinear are 3. the least number of points to be collinear are 3. And I want to demonstrate why. If we can say that point is collinear with that and say this is point A, this is point B, we just need a straight line to ensure that they are collinear. At least, we must require the third point. Assuming C is here, then you can already see that the 3 points are not collinear. The 3 points are not collinear. Any 2 points can be said to be collinear, but not every 3 points are collinear. So at least the number of points that can express collinearity is point A, point B, and point C. At least 3 points to express or to explain collinearity. And I want to repeat for the last time that for the 3 points to be collinear, we have to show that we have 2 vectors which are parallel, and for vectors to be parallel, they must be expressed as a scalar multiple of each other. And the second point, we have to have a shared point. It could be A, it could be B, it could be C, it could be X, it could be Y, it could be anything. But we have to have 2 parallel vectors and a shared point, at least to express collinearity. The least number of points that can express collinearity is 3, not 2. Thank you. Let us meet in the next video.